Hi, everyone. This is the presentation uh, for not being on site today, 423, and I'll probably do it in two parts. Direct your, make sure I get the right, that's digestive. We just finished that. Here we have urinary tract. So I reviewed this PowerPoint and I will make sure it gets posted appropriately. I may or may not have loaded it by that time, but I may even think that I did. But I really think they did a very, very good job on this particular PowerPoint and whole presentation. It's a very complicated area, and because of that, we can't cover it all. I started with a little bit about it, the things that it does. These are the same thing: the filtration, the transportation. This is all about the urine. Very straightforward. That's there. And again, the kidneys are really doing the work. This is just conveyances. Can things go wrong? For sure. So all about homeostasis. So, I mean, all those things, whether it's what is excreted, adjusting pH, volume of body fluids. To me, the most important part, metabolic waste, particularly, again, nitrogenous waste materials. I can't stress that enough. Things in excess, foreign substances, and generally, these are things the liver has made more water soluble because effectively that's what you're dissolving it in to excrete it. And yes, other regulatory hormones are involved. This is pretty straightforward stuff. This is anatomy to me. This is anatomy to me. All of these things just to go over the get water and electrolytes, waste correctly here. Erythropoietin stimulates bone marrow. We've covered that. Renin, which helps with blood pressure, and basically it's that renin-angiotensin mechanism. I'll probably be doing that in class. It's a little bit easier to present it there because I think it's really important. Activating vitamin D, so vital for absorbing calcium in our gut. Okay, and then all the other things that are when things are not functioning, we obviously have to take care of them in some exterior, out of the way point. We won't focus on this. I've seen both of these. As I said, my ex worked at a dialysis unit for about a year, and I've seen them even in the hospital or an outpatient setting do peritoneal dialysis. Hmm. So here they are, the location again, and not much to describe here. They're very, very good. And then this again is the anatomical bases, all those types of things. Really, our focus point for this is going to be on the nephron. Okay. To understand the tooth, if there's one thing anatomical we'll go over is the blood supply. Once again, I'll emphasize it because it's unique and so important to understand, and really the functioning unit, which is called the nephron. The nephron consists of something called glomerular filtration, a nest of capillaries that are fairly unique in particular in many ways. One of which they are fenestrated. Fenestrations mean holes. That's all it means. Technically, a fenestration is just a little opening, a hole like a little window. And what's interesting about that, these capillaries have a whole lot of them that allow fluids and things dissolved in fluid to go out. The only things that really stay inside because they're too big to get through the holes, no matter how much of the holes are exposed, are formed elements. Remember that from blood: red cells, white cells, platelets. Even platelets, these little chunks are too big, and proteins. Other than that, anything else gets filtered out, and hence the name filtrate. That's what happens there. We do filtration through the glomeruli, relying on a high pressure filtration system because of the wide anatomical structure known as the renal arteries. That's the ball game right there, and understanding what happens afterwards and how we reclaim literally 99% of all of that water and all that stuff dissolved in water. And the only thing we don't reclaim are stuff we want to get rid of, and then we can modify that 1%, maybe a liter to maybe as much as 2.5 liters worth of filtrate. Think of how much you go a day urinating. Most of us average about 1.5 to 2 liters a day, and it just depends on how much water you have to reclaim or how much water you have to get rid of, what you've eaten, toxins, any of those things. And we consume them all the time. It's not saying there's anything wrong with that, but I say it all the time. In a relatively wealthy country, we're prone to excess of it, and a lot of times we we ingest too much of stuff that maybe we should think twice about. So, and I like these illustrations. This is a really good view of what's going on in one of those pyramids. Here are the pyramids. There are typically about 7, maybe 8 of these. There's a subtle anatomical variation. And dripping out of the tip of these pyramids, right here, is where the urine comes out. It's called the minor calyx. Remember that. They form into these larger, effectively funnel-like openings called the major calyx. Calyces is the plural. They feed into something called the renal pelvis, and that is the opening for the funnel known as the ureter. That's really what it is. Blood supply comes up here through the columns, and really this is one of the focus points when we start talking about how urine is concentrated. And so when they talk about a renal corpuscle, the corpuscle is the capillaries that are there and the structure that's surrounded that you're going to learn is known as Bowman's, capital Bowman apostrophe S, proper name, capsule. And it's really yet another opening of a funnel. And this is like one of those crazy straws you got when you were a kid. And this is called the proximal convoluted tubule, the nephron loop, and then the distal convoluted tubule. And what you're looking at here are all of these nephron loops for a particular kind of nephron, which is that whole thing, as you can see there, that really are part of this interesting system called the pyramids. There's blood vessels in there. There's something called collecting ducts in there. A lot of these structures. So you have collecting ducts, and the fancy name of the tip of this is called the renal papilla. That's my wife's phone, and she's not here to answer it, so we're going to let it go. So the renal artery off the abdominal aorta, you can see typically at rest about 25% of your blood. It branches, it goes through those columns, which we call lobes, arches over the pyramids into that area. Again, this is called the cortex. This is called the medulla. All the filtering goes on out here in the exterior, the cortex. Basically, the formation of urine and particularly the concentration of urine, in other words, reabsorbing the water, goes on here. It's a very important process. Very hard to understand, doing the best we can. Just showing it to you where it's located, and they're trying to give you that idea. I mean, this is wider, that renal artery, than these. These are the ones going to your gut. That's the celiac trunk. I mean, there's a whole lot of, this is a very wide artery if you begin to look at these types of these. These are the ones going to what are called the suprarenals, relatively narrow, not the renals, very, very wide. What's interesting about that, when it finally branches, and I touched on this a little bit, it's a very odd system. It's the only place in the body where you have arterial oxygenated blood. Oops, double oops. Went right over the top of it. Where you have oxygenated blood going into bed of capillaries, that glomerulus, and coming out with oxygenated blood. And then it leads to then another capillary bed, and what comes out of that is venous blood. And and I'll reinforce it by going into that other PowerPoint when I get the chance. Effectively, you have to understand that in order to create the filtration is a product of pressure. The force that allows us to filter is high blood pressure, relatively speaking, much higher than most capillary beds coming into those glomeruli, and so effectively that creates the filtrate. Once we have the filtrate, now we spend all of the energy that remains in arterial blood is used to actively exchange mostly sodium, and exchange that, reclaim the sodium in the process, even bring along stuff we want to keep and get rid of stuff we don't. And those are called tubular reabsorption. That occurs going back there. Most of the tubular reabsorption and secretion occurs here, about 2/3 of it. In the proximal convoluted tubule, it's got more convolutions than this. Down in the loops, we concentrate water. Okay, and up here in the distal convoluted tubules, we do mostly secretion, not a whole lot, sort of finalizing the urine, getting rid of the stuff that we have to make sure we get rid of. And then out it goes, and then there's a whole series of these collecting ducts, multiple ones of these distal convoluted tubules. What they do is they connect to these collecting ducts. So there's multiple of these loop and this kind of glomerulus or renal corpuscle area, bigger part, this kind of nephron throughout any one of these pyramids. And so they all just are duplicating the same thing. Venous wise, really nothing special. Eventually, all the blood flows from these capillary beds. One's called the peritubular capillaries. They're basically reabsorbing and secreting particles like sodium, potassium, chloride, glucose, those kinds of things. Whereas where you're going to see the vasa recta, which means straight vessel, vasa for vessel, recta for straight, are draped over these very long loops of Henle that you will see. Okay, and again, the proper name is Henle. And what those are where really we're concentrating the urine. So we don't have as many of those, but they perform an extraordinarily important function. And sooner or later, from the nephron, the blood flows into the vein and eventually goes out. So trying to show it to you. This is called a cortical nephron. This is the proximal convoluted tubule. Here's the little distal convoluted tubule coming up. You can see this is an important area up here. We'll talk about that in a bit. And multiple of these nephrons go into these collecting ducts. You can see the collecting ducts are in multiple areas throughout the pyramidal structure. What makes up the blood vessels and all these long loops, again called loops of Henle. These are called juxta, means next to, medullary nephrons. This is all as you can see, the capillary bed is here. These are called peritubular capillaries. The capillary bed is here, called vasa recta. So you can know what it does. This basically reabsorbs and makes sure that the right solutes are being brought back in and the right solutes are being excreted. Tubular reabsorption, tubular secretion. Solutes means just stuff dissolves in the water. And this is all about concentrating the water. It's a very interesting mechanism called a countercurrent mechanism. It has to do with these long loops and the hairpin turns and creating a special kind of a current. We are not going to go into that in detail. Even the advanced students, even medical students, have a tough time understanding that. And here, this just gives you an idea of a cast of how many, it's all blood vessels and tubes. So the inside of the kidney is just very soft and mushy because it's just blood vessels and flexible tubes. Very, very thin, flexible tubes. This is actually what they look like. This is this nest of capillaries called a glomerulus. And you're going to see they're very unique because they have these tiny holes that allow water to pass, and moreover, covering the holes almost like fingers. Okay? They're called podocytes, which means they look like little foot process cells, POD for foot. And these podocytes are finger-like, if you want to go toe-like processes or finger-like processes, can open or close a little bit. And when they open, it allows more filtrate. When they close, it's less filtrate. And in doing so, you adjust blood pressure. When you create the more filtrate, the more you're going to urinate. The less filtrate, the less you're going to urinate. Because the vast majority of the filtrate is water. And so you can reabsorb 99% of it. But if you have an extra liter of water every time, 10 or 15 times that your blood circulates through, you're going to have a fair amount of urine to put out. So for whatever reason, one day it doesn't mean you're drinking, quote unquote, alcohol drinking. For whatever reason, you're drinking a lot. You're just, I feel really thirsty today. Whatever it is, you're probably balancing out for something that maybe you ingested. Maybe you ingested something that was really salty or whatever, and you end up, to balance it out, the body will process everything and determine, oh, you're overhydrated. We got to get rid of extra fluid. This is that interesting one I was telling about. Oopsie. So here you have an arterial in and an arterial out. Again, they have messed this up. Everything was good until they got to here. Through the glomerulus, it is not venous blood. Period. End of sentence. In the other PowerPoint I was demonstrating with the Marie PowerPoint is correctly colored red. This is a boo-boo. So the afferent arterial is arterial blood to the efferent arterial. it becomes venous blood as it makes its way through the peritubular capillaries or the vasa recta. All you got to know about that. Here are the parts: the corpuscle, the glomerulus, the capillary cluster where filtration occurs, and the start of urine formation. And finally, you see the renal tubules, and that's the other part. Those are, they go from there. It's almost like a funnel top again. This capsule, known as Bowman's capsule, it collects it by way of a collecting duct. It feeds into the proximal tubule, the loop. The long ones are really the loops of Henle, the descending and ascending limb, and then the distal convoluted tubules, and multiple ones join the collecting duct. And eventually that whole system, the urine, again, what comes out of the collecting ducts coming out are really where the urine is sort of dripping out of. That's what's coming out the tip, the papilla. This is a very good illustration. See all these slits, and these slits, the podocytes, can control the amount of slits that are open and those that are closed. And so you can see primary podocytes and podocytes. So they can actually alter shape a little bit, be tighter or looser, and allow more filtrate out, because if it's closed, it's going to be reabsorbed back in. Okay, here's what, and this is exactly what, so they're all throughout this area. It's a really good illustration. This is the capsule or the capsular space. Again, this is the start of the funnel. I know it looks like it's upside down, but they're doing that for purpose. The afferent or incoming arteriole is always wider. The efferent arteriole is always more narrow. Okay, and here's this, and imagine as the blood's going through there, it's almost spritzing out, just like you would have on your lawn. If you have one of those, you're watering your lawn, you put in the hose. I mean, if you turn the hose on just a trickle, it hardly does anything. And you see how much it spurts out when you turn the power on. This is the power. Okay, controlling the diameter of the afferent arteriole. The wider it is, the more it's going to spritz. And a couple of things, they're arterioles, so you can open and close them. If this opens and this closes a little bit, then you're going to keep the blood in there really longer, and the longer it's in there, the more fluid's going to go out. So we have unique ways of controlling, and that's the primary way we adjust our own blood pressure. For when we had a little too much to drink, or we're a little too dehydrated, we're very active, we're relatively inactive, etc. Basically, it's auto-controlled. We don't have to think about it, as long as your blood pressure is relatively normal, just by controlling the amount of flow in and the amount of flow out, either opening or closing, widening or narrowing this, widening or narrowing this. We control the amount of filtrate that comes through. The more filtrate, the more urine that we get rid of. That'll lower blood pressure. Basically, taking fluid out of the system, and the fluid creates the pressure. It's a fluid pressure system, versus the more we hold in, the less that flows in here. So if this is relatively narrow and this is wide open, the fluid, it's going to go right through. So you're not going to get a lot of filtrate. And so too, we can retain that fluid. Okay, we can still do enough of the processing not to worry about it. That's the beauty of this system. And so here you can see it. And we're going to get to this area. You can see there's a very close area with the afferent arteriole, and typically the distal convoluted tubule or the ascending limb of the loop of Henle. That's called the juxtaglomerular apparatus, and that is a big, big deal. Not a whole lot to see here. Again, they're just summarizing the sequence of urine formation. Nephrons, you have a cortical nephron. You have, and that's about 85%, is really dealing with solutes, almost entirely in the cortex, short nephron loops. And again, the capillary beds are called peritubular, around the tubular capillary, and the juxtamedullary ones, about 1 out of 6, 1 out of 7. Those are the long loops of Henle. Okay, and as you can see, the juxtamedullary means that the glomeruli are right against that boundary between cortex and medulla, and they're all about water balance, because you're going to see what happens. Water goes out, and the question is how much water goes out and how much is reabsorbed. And that's part of it. And which brings us to the juxtaglomerular apparatus. I will stop here, because I don't want to give too much in such a short period of time. I'll probably do another dictation with this so we can get through most of the kidney, certainly, hopefully finish it when we're in class together on Friday, and move on and spend the last week just doing male and female reproductive. Thank you. We'll talk to you in just next time I get a break.